This is a case M. Before you look at case M, make sure you've reviewed case L, because I'm going to use a different approach, but there's some components of this that are very similar, but I'm going to take a very different approach than all the integrating that we had back in case L. Here we're looking at a PDF that's two linear functions, one in the range of 0 to 5. This gives us the waiting time in minutes, waiting for a bus. So it's the first part is a linear function between 0 and 5. The second part is a different linear function between 5 and 10. And if we're not in this range of 0 to 10 minutes, then it's the PDF is equal to 0 at all other x. So in this problem, let's take a look at what the function looks like. Though that PDF works out to be equal to this case, where we have the linear function from 0 to 5 minutes and another linear function from 5 minutes to 10 minutes, and it's two triangles next to each other is another way to see this, and where the peak value is equal to 0.2 at 5. The different parts of this problem are: first, A, draw the function and verify that it is a valid PDF. Well, you already saw it drawn on the previous slide, but we'll go through the steps and make sure it's valid. And then B, for any given selected, for any day selected at random, what is the probability your total waiting time will be? At most 3 minutes, at least 7 minutes, at least 4 minutes, between 4 and 7 minutes. We're going to solve this next second. So we'll start off with looking at establishing that this is a valid PDF. So to do that, we have to ask the question, is this valid? It's always non-negative. So it's never negative, so it has that property correct. The second question, when you integrate across all values, do you get 1? We're not going to integrate. We're going to do it another way, but I'm hoping that you'll remember that what we can do is simply take the area underneath the curve, and we can see this area can be found. And I prefer right triangles, so I'll have the left triangle and the right triangle. What's the area under the left triangle? The area is equal to 1/2 times, because it's a triangle, it's 1/2 times this leg times this leg from 0 to 5. So we have 5 times 0.2, which is 5 times 1/5, that's 1. But we also have 1/2 because it's the area of a triangle, so that has a area of 1/2, and the other triangle is exactly the same. It too has an area of 1/2. So when you integrate the PDF, we know from 0 to 10, we know that we get 1. So it is a valid PDF. The next part of the question asks, for any given day, what is the probability that your total waiting time would be at most 3 minutes? Well, what that really is asking us to do is to integrate the PDF from 0 to 3 minutes. That's what BI is asking us, at most 3 minutes. But I don't want to integrate. So instead, what I'm going to do is use the area concept further. What is the area of the triangle that lies between 0 and 3? So I'm going to need to get rid of some of this that I've drawn on already. And now I want the area of this triangle. When we look at that, this leg is equal to 0.04 times 3, 0.12. This leg is 3. So 3 times 0.12 times 1/2 is equal to 0.36 times 1/2, which is equal to 0.18. So BI, that area from 0 to 3, is equal to 0.18. The next question that we're supposed to look at asks, what is the probability that it's at least 7 minutes? Well, at least 7 minutes means it's 7 or more. Whoops, whoa, I did not mean to do that. What I meant to do is say that now we want the area of that triangle. That's too easy. By symmetry, I know that BII, the probability that it's more than 7, is going to be equal to the probability that it lies to the left of 3. So that's just the same as part BI. So 0.18. And I'm done BII. For BIII, we want it to be at least 4 minutes. So at least 4 minutes. This is a little complicated, so this is a little complicated, so I'm going to erase this, and remembering that we just asked probability that it's at least 4, that's going to give us this area that we're interested in. I'm not going to calculate that area. Instead, I'm going to calculate the probability that it's to the left of 4. So with this shading, I'm going to find the area of that triangle and get the one to the right as 1 minus this. So the area between 0 and 4 is equal to 1/2 times one leg is 4, and the other leg is equal to 0.04 times 4, which is equal to 0.16. So that I have 0.32, which tells us that this area is equal to 1 minus 0.32, which is equal to 0.68. I already calculated this, and it was equal to 0.18. But we don't have BIII, which is the probability that it's 4 or more, and that's we just found to be equal to 0.68. The area shaded on the right here. And next we want BIV, and let's just look at what that problem asks for. BIV asks for the probability that it's between 4 and 7. So if we go back here, we want the probability that it's between 4 and 7. Let me clear some of this scribble off. Between 4 and 7. Well, to get that, we will probably find it easiest just to find the areas of the two triangular portions that aren't shaded, and then subtract 1 minus the area of the two triangles not shaded. This first one we have from part BII. We know that this one on the right is 0.18. The one to the left we just found in the solving for BIII. We found that this one was equal to 0.32. So BIV is equal to 1 minus the quantity 0.18 plus 0.32. Let me rewrite that. BIV is equal to 1 minus the quantity 0.18 plus 0.32, and that is equal to 0.5. 1 minus 0.5 is equal to 0.5. So we've solved that part of the problem, and I'm going to take a break and come back in a second video and solve the second part of this case M.